Hello everyone. So in this video I'd like to talk about this project that I have been working on for the last few months. It's a GPS tracker for my dog so that I can find him if he gets lost. So it consists of two parts. This is the transmitter which attaches to your dog, and it transmits its GPS location via LoRa radio. And this is the receiver. This is what you, the owner of the dog, would carry in your backpack. And it is pretty big. This is my hand. I've got fairly big hands and it's a bit taller. So the way that this works is that you get your smartphone. This emits its own Wi-Fi network, so you would connect to the Wi-Fi network with your phone, and then you type in the IP address of this receiver into your browser, and then you will be presented with a map showing the location of the dog, and I am going to demonstrate that later in this video. And the beauty of this is that no internet connection is required, and it works totally offline. So if your dog goes missing in the mountains when there is no phone signal, this will still help you find it. So the microcontroller which powers this is the ESP32. The GPS module which receives the location data of the dog is a Neo 6 MV2. The transmitter module is an RFM95. Now, most projects similar to this one on YouTube use the Adafruit RFM95 hat. However, that costs £20, while this only costed me like £5 or £6 on eBay, so this was a great way to save money. Although I've had to manually solder on these cables onto here, and it doesn't have nice spacing to solder on header pins, but it was still alright. And for this antenna, I have used a thick copper wire. Well, by thick I mean like 1mm, because I thought this was gonna improve range. I'm not exactly sure if that is better than using a thinner wire. And this is powered with an 18650 lithium-ion battery, which I got out of an old power bank, and the case from this battery is from a power bank as well, this plastic thing here, and the battery life is about 5 hours. Now I got this charger booster module here off of eBay. So you charge your battery by plugging in your micro USB cable into here, and also it steps up the voltage from the battery from 3.7 volts to 5 volts in order to power all this circuitry. Also, the antenna for the GPS is stuck to the top of this battery in order to have the maximum GPS signal strength. Now, to be honest, I did have a bit of a bad time regarding the GPS antenna, because I have been fiddling around with the antenna too much, and then the cable here had broken off, and then I was getting no GPS reception, and it took like half an hour for the GPS position to fix, and then I just kept troubleshooting and finding out why that was, and then I realized it was because of this broken cable. So I've had to buy both a new antenna and a new GPS module, which wasn't very efficient, but it was still the most cost-effective option. So everything is packaged in an IKEA cardboard box. It is nice and rigid and does a good job of protecting all the components. So here is a Raspberry Pi 3 Model B, and it's connected to the LoRa receiver. It's exactly the same module as in the transmitter, It's also an RFM95, and it is powered with a laptop battery, which I am going to get to now. So to do this, we have to remove the Raspberry Pi. Everything is held together by Velcro, and it does a good job of holding everything together. Now, I did have to hot glue some pieces of cardboard to this Raspberry Pi case, so that when you shut the lid, the pressure holds everything nicely in place. So you've still got to remove the Velcro of this battery here. So this is a laptop battery. I mean, my other option was to buy a power bank. This would have saved a lot of space, but I wanted to make use of the stuff that I've had. So to charge this battery, I just have to remove this screw here and then put it into my laptop and then charge it up, and when it's done, I take it out of the laptop and then put it back into here. Now, I've had to make this battery holder myself, so I sawed out a piece of MDF, and if we look here, I've had to hot glue these metal shunts here, and they go into the positive and the negative terminals of the battery. And now this piece of paper here is to protect against short circuit. And also I've hammered in these two nails here which go into the slots of this battery, and that helps hold the battery in place. Now these two nails do stick out here. I did think about chopping them off, but they don't cause any problems the way they are, and also that holds the converter module, which I'm going to talk about later, in place. Right, so in this junction box here we have a fuse wire which is meant to protect the battery from short circuit. Now, there is no percentage indicator or power level indicator for this battery, so what you have to do is that you have to stick in your multimeter leads into this junction box here and then measure the voltage of the battery, and that gives you a rough idea of how much energy remains in the battery. Now, we've got this voltage converter here. This steps down the voltage of the battery, which ranges from 8 volts to 13 volts, down to 5 volts used to power the Raspberry Pi, and it's made from an old car phone cigarette lighter charger. So what I've had to do is that I've had to saw off the plug bit and solder in 2 wires which are connected to the battery. So the transmitter runs a sketch written in Arduino C++. What it does is that it takes the location from the GPS module and transmits it to the receiver, which the owner carries using LoRa. Now, the LoRa driver is one that I've had to write myself, but it is based on the Arduino LoRa driver written by Sandeep Mistry. Now, the issue with Sandeep's driver was that I was unable to receive messages on the Raspberry Pi. Now, it took me a long time to find out why that was. I first thought that there was an issue with the ESP32 not providing enough power for the transmitter, but then I put in a better power supply and that still didn't fix the issue. So then I thought it could have been pseudo permission errors on the Raspberry Pi, or maybe bugs in the driver, or me using the driver incorrectly, and I tried experimenting with all these things, but sadly that didn't fix the issue. However, when I was looking at the code for the drivers, I realized that the way that they were handling headers was different for the transmitter and the receiver. So what I have decided to do was that I have rewritten the transmitter driver in C++. I have written the SPI commands in the transmitter driver so that they exactly match the SPI commands in the Raspberry Pi transmission driver, and I've had to look at the datasheet of the RFM95 to just make sure that I knew what I was doing. And then once I did that, the Raspberry Pi was finally able to receive messages. Now, in order to be able to successfully obtain the GPS information from the GPS receiver module, I've had to write my own NMEA parser. Now, what is an NMEA parser? So, basically, GPS receivers output their data in this format called NMEA, and actually it's a standard. It's used by the military. Now, if you want to know more about NMEA, then you can follow the link in the description. Now, there is this well-known NMEA parser for Arduino called TinyGPS Plus, which I was first using, but unfortunately, when I started implementing sleep mode on the transmitter in order to save battery, I started to have issues with the GPS. So, for example, it was unable to read the GPS location every other time the transmitter was transmitting data to the receiver. So I've had to do was to write my own NMEA parser, and that fixed the issue. Running on the Raspberry Pi in the receiver is the Python server, which is the core component. Now, this has two purposes. First one being receiving the location data from the RFM receiver module, and the second one being hosting a web server for the web page that the owner of the dog would open on their smartphone, on which they would be able to see the location of the dog. Now, the driver that the Raspberry Pi is using to communicate with the LoRa receiver is the Pi LoRa RFM9X. Now, finding this driver was a challenge because most Raspberry Pi projects did not have the Raspberry Pi directly connected to the bare RFM95 module. Most of them used the Adafruit hat, but of course I was saving money, so I didn't do it that way, and I spent ages searching through the internet until I finally found this driver. And then, of course, I've had problems with the Raspberry Pi not being able to receive data from the transmitter, which I've already talked about. Now, for the web server, it uses the Flask library for Python, which is a very popular library. So the client, which is the smartphone, uses Ajax to fetch the location data from the server, and it does that every second. Now, for the Sleepy map, which shows the location of the owner and the dog, that uses OpenStreetMap, and that was basically my only option because this runs offline and also it is free and open source. Now, the library that I have used to show the Slippy map was OpenLayers, which is a very popular library for this purpose, and that uses Node.js. Now, another important process that runs on the Raspberry Pi is the tile server, which has the purpose of rendering the bitmap map tiles which are displayed on the Slippy map on the web page. If you want to know more about tile servers, then you can check out the link in the description. So to set up the tile server, I followed the instructions on the OpenStreetMap website, and I did everything manually. So I've had to set up the PostgreSQL database and install Mapnik, and unfortunately I've got an error in the way which I was unable to fix. So I was wondering if I could do it via Docker instead, because Docker is really helpful in those circumstances because you don't have to set up things manually. And then I did find this Docker image on GitHub by over-V. So I was trying to set it up, which took a lot of time because my Docker knowledge was fairly poor, but learning about Docker was relatively easy and I managed to get it to run. And the first issue that I faced was that the tile server took a very long time to start, which is like 3 minutes, and I'm sure the owner of the dog doesn't want to wait that long. And then I identified the cause of this, which was that the style sheet had to be generated every time the tile server starts. So the solution was to create a volume with this tile sheet. So when it came to showing the position of the dog owner on the map, I've had to use the JavaScript geolocation API to do this, which basically accessed the smartphone's location data. Now the problem with this was that for security reasons it required the web page to be in HTTPS instead of HTTP. Now to have the web page in HTTPS, you need a certificate signed by a certificate authority company, which costs you money. Or you could generate certificates yourself, but then you would have to import them on your smartphone, which is quite finicky. So what I did is that I used the ad hoc certificates feature on the Flask Python library, which basically generated some dummy certificates on the fly. And this managed to solve the problem, although when I opened the web page on my laptop, I was presented with the classic "your connection is not private" screen, but I was still able to go on the web page. Now unfortunately, when opening this on my smartphone, on the Chrome browser, the browser just refused to show the web page, and I tried Firefox as well, and same thing happened. So then I spent some time trying to find a browser which still allows you to go on unsecure sites, and I eventually found this free and open source browser called Fennec, which worked quite well. Alright, so to turn this on, first turn this toggle switch on, and then this secondary switch here. And as you can see, that powers on the Raspberry Pi. You can see the LEDs flashing inside. To power up the transmitter, just take this cover off, and inside you have a switch. You just need to turn that on, like so. Alright, so connect to the Wi-Fi network of the Raspberry Pi. It's called Ryan Tracker because my dog's name is Ryan. So then we open up the browser, Fennec. Just need to refresh the page in order to make this work properly. Here we have this secure connection screen. Accept the risk and continue. Okay, so we should see the map. I'm gonna focus me. Alright, our map is just loading. So right now I am literally standing next to the transmitter. Now if I start moving, you can see the blue dot move. And I'm gonna head back to the transmitter. And now we should both move. If I just rotate my screen so that you can see better. Right, so I'm now walking with the transmitter. And Now unfortunately the transmitter transmits once every 10 seconds. This is to save battery, so we should see the green blob move in a bit. There we go. Right, so we've got the coordinates here. We've got this copy subject location button. This is so that you can quickly copy and paste the coordinates into the sat-nav. If you want to use your sat-nav to find your dog, then you've got the buttons focus subject. This focuses your dog, and this focus me focuses you, the owner. Let me just show you about how quickly this map loads. You can zoom it in, out, and then rotate. And because this is on the Raspberry Pi, which is relatively slow, it does take a bit, but it does work in the end. Now if you want to shut down the transmitter, you don't disconnect the power supply. You need to actually shut it down from the system, because otherwise you may corrupt the file system. So what you need to do is press the power off button here, and then you'll be presented with this confirmation dialog. So we're going to hit OK because we want to shut it down, and it will shut down in a few seconds. So, in conclusion, I think this was a really fun project. I've learnt lots, and also I think lots of things are good about the way this works, and it can come in really useful for dog owners. Now, in terms of the improvements, first thing is that I would leave the map rendering to the smartphone instead of this Raspberry Pi, because this is quite bulky and annoying to carry. And also, it would definitely improve on the construction quality of this, because everything is so loosely held together. If you take a look here, it's just secured to this bit of plastic to prevent these components from shorting out. Everything is just taped, and that is just really unprofessional. But I think this works fine for the first prototype of this project. So I think as an improvement I would use perf board or something to keep everything more tightly held together. Now, another thing is that downloading the maps on this takes a really long time, and this means that if you are moving house or going out with your dog far away from home, it is really difficult to download a map of the new area, because the current setup that I have doesn't allow easy and efficient updating of the maps. And also, going back to this transmitter here, this switch also isn't in a good position. It can short out with other pieces of metal because it is made of metal. And also, I definitely should think of a better way of waterproofing this. But overall, I'm really pleased with the project, and I may come back to it later in the future to try and do the improvements that I've mentioned.